In the previous presentations, you have learned in detail what the purpose of Cardiomatics is. Now it's time to approach another question. How does Cardiomatics work? From the user's point of view, Cardiomatics must be useful and easy to use. So, let's review what happens as soon as a Holter ECG exam is taken from a patient. The first step is to download the recorded signal from the recorder to an external device, e.g., a computer. Then, using the account in the web application, the signal is sent to the Cardiomatics platform. After the signal has been sent, automatic analysis based on artificial intelligence models is run on the servers. After the analysis has been completed, the report is automatically generated, confirmed by a quality assurance team, and made available to the user in the web application. So, what is the difference between traditional software and AI-assisted software? With traditional software, we define the problem we want to solve at the beginning. The problem may be, for example, the appearance of the web application for uploading ECG signals. Then the code is created which, after appropriate testing, is made available in the form of a ready solution for users. In the case of software using artificial intelligence, the process becomes more complex. The model undergoes a machine learning cycle. This is a cause and effect sequence that leads to product improvement. The first step is a business case or error analysis of the existing system. An example would be a user group that reports the need for our product to detect the next type of arrhythmia. In response to such a need, we formulate a research hypothesis and plan an experiment. We define the limit values for diagnostic parameters. When these have been reached, the model can be added to production. An example of such a diagnostic parameter may be the sensitivity of the algorithm to specific types of arrhythmias achieved in special test sets. The next step is data preparation. Such data must be collected and properly described. Then we proceed to train the model. Everything is thoroughly tested on additional data sets that do not participate in training. Thanks to this, we have independent and reliable information about how the system will cope in real conditions. Positive result leads to the implementation of the model, whereas a negative to a reanalysis of the created system. An interesting fact about how models are practically developed is the apparent number of signals transformed by Cardiomatics. Counting the number of signals received from patients gives a total record length of 213 years, or 168,000 kilometers, which is more than 4 circumferences of the Earth, or half the distance between the Earth and the Moon. This represents more heartbeats analyzed than the number of people on the planet. Despite the fact that we receive signals from distant countries such as Australia, South Africa, and India, the majority of our users are from Europe. More than 800 physicians have already trusted us. Outside of clinics, Cardiomatics is used by cardiology specialists and general practitioners. In both cases, Cardiomatics is complementary to their work in various ways. Positive feedback reassures us that we're doing the right thing. That's what happened during the COVID pandemic, when we saw an increase in patients needing Holter ECG examination, and using artificial intelligence allowed us to manage the limited healthcare resources wisely. Users, especially those who have been working with us for a long time, have drawn our attention to the fact that the analyses provided in the form of reports are practical and clear. We are constantly focused on developing our algorithms. This could not happen without the clinical background that allows us to provide new training models and validate them before introduction. The clinical project we are involved in is with the University of Basel, where Cardiomatics is being used as a tool to detect atrial fibrillation in the Swiss population. The aim of this study is to increase our knowledge of the association between changes in AF burden and its health consequences. This study included 2,500 patients from 14 sites across Switzerland. Scientists decided to employ cardiomatics technology to extract the most important AF parameter from long-term recordings. Cardiomatics is responsible for optimizing the research process and ensuring that the 7-day Holter ECG analysis is of the highest quality. Another project to analyze 7-day Holter signals is a collaboration with a hospital in Denmark. The aim is to analyze the correlation between SARS-CoV-2 infection and deterioration of cardiovascular performance, in particular the occurrence of arrhythmias. We have also been awarded funding for the development of a pediatric ECG analysis algorithm, Cardiomatics Junior, in cooperation with the University of Warsaw. We believe that we will be able to create a solution that will also help pediatric cardiologists. If artificial intelligence and ECGs are an interesting combination for you, you can find answers to many of your questions on our website, where articles related to cardiomatics, such as medicine, AI, or IT, are posted. We are also active on social media. Our multidisciplinary team is growing all the time, bringing together people from different fields, so you could be the next member of our team.